How to reduce inductor noise in switching converters. Imagine your power system humming quietly instead of making a high-pitched whine. That's what reducing inductor noise can do for your electronic projects. When you work with switching converters, like buck or boost types, inductor noise can be a real bother. It's caused by rapid changes in current and magnetic forces inside the inductor. These vibrations can produce both audible sounds and electrical interference that affect your system's performance. Switching converters use inductors to store and transfer energy efficiently. When the switch turns on and off quickly, the inductor's magnetic field expands and collapses rapidly. This causes the core and windings to vibrate, creating noise. If the switching frequency falls within the human hearing range, you might hear a high-pitched whine. High ripple currents and poor inductor construction can make this worse. For example, loose windings or cores that aren't bonded tightly can increase vibrations and noise. One of the best ways to cut down on this noise is to choose the right inductor. Look for inductors designed specifically for low acoustic noise. These often have tightly bonded cores and windings to keep vibrations minimal. Also, pick an inductor with a higher saturation current rating. This prevents core saturation, which can cause more noise. Shielded inductors are another good option because they contain electromagnetic fields and reduce both audible and electromagnetic noise. Adjusting the switching frequency is also key. Operating above 20,000 Hz moves the noise out of the human hearing range. Some designs use frequency dithering or spread spectrum techniques. These methods spread the noise energy over a wider frequency band, making the noise less noticeable. This is especially useful in sensitive environments like renewable energy systems or power grids. Filtering can help too. Adding LC filters at the input and output of the converter reduces high-frequency noise. A pi filter, which uses a series inductor and shunt capacitors, is very effective. For sensitive electronics, placing a low dropout regulator after the converter can further smooth out ripple and noise. Good PCB layout and mechanical design are also important. Secure the inductor firmly to the board to prevent vibrations from transmitting. Keep high current paths short and use proper grounding techniques to cut electromagnetic interference. Position the inductor away from sensitive parts and consider shielding if needed. Controlling how the converter operates can make a difference. Avoid modes that cause the switching frequency to dip into the audible range. Use advanced control schemes that keep the switching frequency above 20,000 Hz, even when the load is light. This keeps noise levels low and your system quiet. Finally, addressing electromagnetic interference with ferrite beads, snubber circuits, and proper decoupling helps suppress high-frequency noise at switch nodes and outputs. These steps work together to make your power systems more reliable, efficient, and less noisy. Whether you're working on renewable energy inverters or battery management systems, reducing inductor noise improves both performance and user experience.